Hello everybody, welcome to our next webinar in our series about mastering AI implementation to bring energy efficiency and optimize technical operations. My name is Pavel Filonov. I am an AI expert in Hyper-IT company, and today we will consider the next step in about data preparation, the really important step before we actually go to any model training, which will possibly increase our business metrics, the topic we described in our previous webinar. So our agenda for today, after a short introduction about the company and myself, we will go straight to this hype word about big data. And actually, if we will try to decompose what actually engineers means when we're dealing with big data, we will be speaking about three V's, triple V's of big data: velocity, volume, and variety. And it's a really important topic considering different energy efficiency and property management systems, because usually in such kind of system we must deal with different types of data, and some of them really have large volumes and velocity of input sources. And the next topic will be data labeling, a really important procedure. In some cases, actually in some scenarios of model training, we can skip it. But those models, we will call them unsupervised machine learning models, usually can provide only first view of some kind of anomalies of data structure in our system. If we want to achieve the real good context and real actionable detections maybe of some kind of predictive maintenance systems, we must also consider in this usually a manual step of data labeling. And at the end, we will discuss a little bit about data versioning when we actually will need it, or in some types of data, we can just have a single version, maybe the best, just have the timestamp attached to it. So let's go through about the company. The main mission of PPS company group is to digitally transform real estate management, and actually company provides few solutions, few software solutions to different stages of building management, from design, from building process, and to operations. In our webinar series, we will be mainly focused on the last stage of operations, and here the platform Hyperware and Hyperit, the part of the PS Group company, which developed this product, will take place. Usually when we're dealing with already gathered data, the data which goes to our system in almost real time, it's mostly we're speaking about operation of already completed buildings with different type of sensors and technologies. So here our bird view of main topics we will be covering through all of our webinar sessions. The previous one was about business understanding. Please feel free to take a look on the recordings of this webinar, and today it will be about data preparation for model training. So the importance of these steps can be easily described by this funny picture, but actually it's well-known sayings in machine learning world. If you have garbage data in, all you can achieve is some garbage outputs of models out. So in machine learning and artificial intelligence, the interesting and tricky part, what we actually will be focusing mostly not on algorithms, machine learning models, large language models, and so on. It's the important step, but not the primary one. The primary one is the data we will be dealing with. If they have correct data on the input for training and for inference purpose, and we have the good labels, which actually introduce some kind of expertise knowledge in this system, only in this scenario we can actually achieve some kind of interesting results after model training, and we can also achieve the helpful and useful results as this model's output. If we will just try to use some data without any understanding of its quality of its labeling, we can trace something. This something will even produce some outputs, but if we will try to use these outputs as our business insights, usually we will just fastly understand what is mostly the garbage. So it's the funny picture to remember why the data preparation step is really important one in all pipeline of applying machine learning models to different business processes. And here, usually in a lot of situations, we will be dealing with so-called big data scenario. And usually it's the type of systems and storage, first of all, the storage of the data, which will face the three challenges. The challenges of volume of data to handle with, the velocity of input data sources, and the variety of data types. So let's consider all three these separately and try to figure out what actually steps should we implement before we will actually face the process of data gathering and preparation. Volume. Sometimes when we just start operation in our system with some kind of ML models in it, usually, yeah, we can start with a small amount of data. It will be, say, maybe less than 10 gigabytes or even just about 10 gigabytes or more. But actually, on even early stages, we should plan how the system will grow. And if we speak about the long-range operation on large-scale manufactured buildings, in no time, almost this amounts of data will grow from gigabytes to terabytes, and this actually can be easily achieved. And in some cases, if we gather some not only the structured data, not only time series, but maybe some kind of multimedia data, recording from the cameras, photos, and large documents. In some cases, we can, in long range scenario, even achieve the petabytes. So the storage system must be good enough to face with data volume increase. And this also means what actually on early stages of operation, we should start with capacity planning. Well, for example, for today, we have just 100 gigabytes data. And usually we can choose any storage solution to handle this little amount. And usually each even can fit on one server. Or it's maybe a good idea to have one storage server and one backup server separately. But if we want to have the capacity planning, because in usual machine learning scenario, it's really a good idea to store almost everything we can actually get in digital forms. Because maybe in latest scenario, maybe a few years later, data scientists will figure out some additional ways to use this raw data to achieve some interesting business results. And if it's possible, if it's will fit in budgets, the good strategy will be just to try to save as much raw data as you actually can. And this means what you should also do the capacity planning. How much data storage increase you will have year by year. And this means what your storage system must support their horizontal scaling. So it's not will be just the single server. We will just configure it and it will be running forever. No, usually it means what we must limit our storage solutions to data storages what can actually horizontal scale in time. just by adding, for example, new storage servers to it according to our capacity increasing plan. That's the main questions we should ask before we actually start to operate in the system, understanding that data volume will actually grow in time. The next step will be the velocity. It's really interesting patterns in data access in a lot of actually operation and monitoring system. Usually it's the scenario when we have a lot of writes. We write the time sensor data, we just store the images, pictures, maybe from camera system and so on. And usually that's the append only immutable data. When we understand what our raw data actually have this kind of qualities, we can choose the right data solutions, because in old ways it's usually mostly the SQL-based storage systems, which mostly was used to perform some kind of online processing, lot of writes, lot of reads, data changing, and so on. But in machine learning scenario, it's mostly about the writing the raw data with a lot of amounts of it, with really not frequent reads. And usually it's mostly about the immutable data. For example, we will, from one of our automated cameras, we will take a photo and we will store this photo, and usually it will not change at all. And the third bullet here is about fast data processing. In some cases, the actual raw amount of data is really large. Usually when we deal in, for example, with time series with really small time deltas of measurements. And when we're dealing with multimedia, for example, we will try to record even the videos. When we have such large velocity of input raw sources, sometimes it is not possible and it is not actually useful to store all of them. If we need to filter out, make some kind of aggregations, for example, dealing with time series, maybe we should just aggregate the sensor data by minutes or seconds, because some sensors can have even less time resolution, and store only this aggregated data. The same will be, for example, for photos and videos. This will be will allow us to make the better capacity planning, but this also means what before the storage system, we actually will need a fast data pre-processing system, because it will just pre-process raw data on the fly, store only the portions on or only the aggregates we actually will need later, and throw away or store in some, just for some amount of time, the actual raw elements. And not all of actual classical storage system have the data pre-processing built in. So usually it means what our data pre-processing system should be the separate solution near the data storage. And the last but not the least, it's the variety. By variety, I mean here the different data types. As I already mentioned, there's some structured data, maybe some scans and documents about the contracts, about equipment, even the equipment documentation, for example, which will be helpful for large language models to be dealing with providing some kind of action plan about the predictive maintenance, photos, videos, and so on. And this means that our data types is actually have a larger variety, and sometimes it's not the good idea to have just one single data storage solution for all possible data types, because usually it will be overhead in some situations. So from these different data types idea, we came out with the solution about separate storage types. And in modern systems, you easily can see the 2, 3, or even 4 different database management systems. Each of those are used for concrete specific data types to store with. But when we some kind of split the data by types and store it in different storage systems, we usually will need one point of all information. So some kind of entry point with description of all of data in our system. And it's a good idea to have a single metadata storage. It's usually store information, data about the data, what kind of data, where it actually stores, some kind of references, identifiers to actual storage data, maybe some timestamps about data creation and so on. And this single metadata store can be the entry point for automated systems inside. So first of all, we can just go to the metadata store and find out where our pictures actually stored it. It can be showed, for example, if we consider the hyperware platform here. Here are some examples of different data types stored inside. We have the 3D modeling systems, which represent actually by large artifacts. We have some schematics of the system. We have also the time series from different sensors, which changed in time on the top right slide. Actually, we must store the pictures of systems, even the 360 degrees pictures, to make some kind of little animations and the little effects of visualization of different parts. And this means that actually inside the hyperware, we have the separate storage subsystems for different types of data. And speaking about actually the interesting point here also will be providing the interface for this data, which could be accessed not only from the user interface of hyperware, but also from the automated APIs. It's really important in our modern area of large language models, which can be augmented with additional data sources and context. And some companies already provide the drafts about possible contracts and APIs, for example, NPC APIs, how a different system which store actual data can provide this data to be used as the LLM contexts. And hyperware also provides the access to all of this data through the really easy to use APIs, and our experiments with our own hyperbot actually shows that this system can easily use the automated APIs to gather some data and business insight into it. Speaking about the architecture of hyperware, here the simple picture, but actually it's little bit simplified actual architecture, but we have the metadata, which usually have some kind of structures about what data portions we have, what the timestamps of its creations, and maybe some versioning, and the references. What actually this type of data is. It's a time series, some kind of binary data, maybe some structured data, and the actual references by identifier to 3 separate storage subsystems, which each of them are really well chosen to the data type it will store in all hyperware. Because sometimes you can use this binary data storage to store everything, but you will face the lack of maybe analytics reporting and using just simple SQL queries. And if we're speaking about time series, it's usually a really context-dependent system with their own even languages to gather the data and aggregate it through the queries. It's the main ideas about this triple V idea of big data. And after we actually have the data storage, which will face all the 3V challenges, we should start speaking about the data labeling procedure. The idea of data labeling is mostly about introducing the human-made expertise about what this data actually means. Because as I said before, in some situations, we can just use the raw data from the scratch to provide some machine learning results, but it will not be really useful in some scenarios. So in machine learning, from the top view, we usually have two types of problems to solve, two types of machine learning models. It's the supervised. For those models, we should provide the input data and also the expected outputs. And those expected outputs are usually provided by the human experts. And in unsupervised scenario, yeah, we can deal only with raw data and try to build these models from the scratch without data labeling to solve some sub-problems in all possible machine learning scenarios. For example, here also the results of unsupervised machine learning models from which runs inside Hyperware platform, the anomaly detection one. The anomaly detection, it's a sort of problem which can be formulated in unsupervised way. And feeding all of possible time series data into these algorithms, they can actually came out with detected anomalies. It's usually the some subsets of variables and time range where the variable behavior or group of variable behavior looks anomalous one. But the only description those anomaly detection algorithms can provide is just simply it's some kind of anomaly. It's unclassified one. Because in a variety of different systems, variety of different variables, different patterns of this time series mean something different in every situation. So a lot of differences here. And anomaly detection couldn't actually do some kind of classification or actually action planning, just highlight the time window and maybe highlight the variables which we actually should focus on. But it's a good idea maybe to have the all possible models built inside the platform. For example, after this anomaly detection, we can ask the users of the system to provide some kind of manual labeling. And the users, they can create these annotations by themselves without any anomaly detection services, or they can annotate already created anomalies and add some descriptions, add some classes actually. Some of them may be actually even labeled as false positives. So we will not need these anomalies in the future. And in this description, in these classes, usually it's some kind of context specific. Usually only the real users of the system can deeply understand what this situation actually means and what's the severity of it, what will be the priority of this anomalous workflow. And using this manually labeling Hyperware platform actually can also provide the supervised machine learning results. So after you manually classify those time ranges or already detected anomalies, the new detections could be augmented with these classification results. And you will see not just some kind of unclassified anomaly, but we think that this may be close to controller reboot. So you can already have some kind of context what possibly happens in your system. And good results in this classification of anomalies, for example, it's usually provided by the good quality of manual labeling. And speaking about the last topic for today, about data versioning. Usually some types of data in machine learning actually have no versions at all. The good idea will be to have the data timestamps, which, for example, will be the creation of this data. But because of data typically is immutable, they will not have versions at all. But it's not the same for labels, because usually labels it's a manual process, and yeah, the machine learning models can make mistakes, the humans can make mistakes, and this means what labels can actually change over time. And to have the property of reproducibility of our machine learning training results, we should also should be able to train our model on exact the same version of data labels, for example, on this timestamp. And if the labels will change in the future, yeah, we can retrain our models. But if we will not have all the versions of this situations, we can actually lose some kind of information from the past. So also, when you are planning to introduce the AI technology and machine learning technology in your products, you should not forget the possibility and functionality of this data versioning. Maybe not for all of data, but the labels actually the one that should have the data versioning system, because labels can change their minds, the classes may shift from one another, and so on. So I think that was the main three ideas about the dealing with big data freebies, data labeling, and data versioning, which are important steps to data preparation for model training. We will cover the process of model trainings and the pitfalls of it in our next webinar series. So please stay with us and subscribe to our LinkedIn page to be informed about new webinars when we will be speaking about model training procedures. And I think it's a good possibility to have some Q&A section. So please feel free to use chat to ask any questions which are interested to you, or if you see this webinar in recordings, please also write your questions under the post. Our team will answer them, and maybe we'll have some good discussions about. The question is how to organize a secure data exchange of corporate data in public LLMs. It's a tricky one. It's a tricky one. From my point of view, it is almost impossible dealing with public LLMs. Yes, when you have a paid subscription to public LLMs, actually some of them mentions what for paid subscriptions, they will not store this data and use it for train the future models. But it's just the legal terms. And maybe the truth is a little bit different. So we have some kind of theoretical approach of, it's called the differential privacy ideas, and even using the cryptography in machine learning. But on this point of time, it's mostly theoretical approaches. Actually, I didn't see real life applications of it. So the only thing for today is to do not use public LLMs if you really have some private or secure data inside your perimeter. You should consider the really expensive scenario of deploy some kind of open source LLM inside your security perimeter. And I think it's for this time the only possible solution where you can actually control the data you exchange with LLM. So the public LLM, you should trust the provider and trust the terms of usage. Thank you for a really good question. And so, if it was all of the questions, thank you everybody for attending this webinar, and also if you see the recordings, please subscribe to us if you want to stay in touch. And we will also announce our next webinar. We will be talking about the model training. Thank you and have a good day.